But now we'll see about infiltration anesthesia. It is administration of the local anesthetic solution intradermally or subcutaneously or submucosally across the nerve path that supplies the area of the body that requires anesthesia. Okay, so that is infiltration anesthesia. Later on we'll see in the injection procedure that where actually this infiltration anesthesia are been given. Now suppose this is any part of your body where there is some kind of cut, and this cut you need to stitch. So for that reason you will be infiltrating it with your local anesthetic. Okay, you are giving injection of local anesthetics. Now suppose you have given subcutaneously these local anesthetics. So next what happens, these local anesthetics, apart from producing its action over here, because these local anesthetics also produces vasodilation, because of which these local anesthetics will move into your systemic circulation. Okay, apart from producing action in the target area, it will move to the systemic circulation. Now suppose it moves to your brain and to your heart. Okay, okay, so what is happening over here, we have given local anesthetic agent over this area, which is an area of target of action, but because of vasodilation these local anesthetics has been moved from the target area to other systemic circulation. Okay, so the first disadvantage is short acting. Okay, why it is short acting, because as such we have our intention was to produce action in the localized area, but because of the circulation, because it enters into the systemic circulation, it has been moved from this target area to any other area, because of which the first problem with these local anesthetic agents are these are short acting. Apart from this, they will move to the systemic circulation, they will move to other organ where they may produce some kind of systemic toxicity. Like if local anesthetic moves to the brain, it may produce seizures, convulsions, and if it moves to the heart, it may produce adverse effects such as arrhythmias. So second problem with these local anesthetics are it produces systemic toxicity. Okay, now why this short acting and systemic toxicity has been occurred, because of the movement of the local anesthetic from the target area to other areas. Okay, now how can we solve the problem? Yes, we can solve the problem by providing a vasoconstrictor such as adrenaline. Okay, so what happens when vasoconstrictors are been given, suppose these are the blood vessels via which these local anesthetics were been moving to other areas. When we are constricting these blood vessels, obviously the local anesthetic will be trapped in this area only. When these local anesthetics will be trapped in this target area only, so it will produce action for a longer duration of time. Okay, so with the help of vasoconstrictor like adrenaline, it increases the duration of action. Apart from this, when these local anesthetics are not moving to any systemic organ, obviously systemic toxicity will also be solved. Okay, so with the help of these vasoconstrictor like adrenaline, we can solve two problems faced by local anesthetics, that is we can increase the duration of action, and plus we can inhibit the systemic toxicity. So for this reason local anesthetics are usually given along with a vasoconstrictor such as adrenaline.